I am Anil Kumar. Welcome to my series on equivalent rational expressions. In this video, we are going to discuss three examples. Now, these three are actually difficult examples on this unit on equivalent rational expressions. You need to simplify each rational expression and state restriction. Question number 1 is 7x squared minus 31x minus 20 divided by x squared minus 25. Question number 2 is 6 times x plus 2 minus 9 over x plus 1 times 2x plus 3 minus 1. Question number 3, I have actually modified. So what I've done here is I've given a simplified form also and now change the question to if 6x squared minus 7x minus 3 over 12x cubed minus 6x times x squared plus 8x plus 16 over 2x squared minus x minus 3 is divided by x squared minus x minus 20 divided by 20 minus 2x squared is equivalent to minus 3x cubed plus ax squared plus bx plus 4 divided by 3x times x minus 5 times 2x minus 1. Find the value of a plus b, the coefficients of x squared and x. And I have created a multiple choice question. Your options are a plus b is minus 1, 0, 1 or 2. Correct? You can now pause the video, answer the question and then look into my suggestions. So let's begin with the solution of the very first one, which is we need to factor numerator and denominator to find equivalent rational expressions, correct? So in the numerator, we have 7x squared minus 31x minus 20. To factor, we need product and sum. So my strategy is we need product of 7 with 20, right? So with the negative sign, so it's minus 20, right? So we can say that 20 is like 5 times 4, right? So if I take two terms p and q as 35 with a negative sign and 4, I could actually factor the numerator, correct? So I hope you understand what I'm trying to do here. Let's factor numerator. So we have 7x squared minus 31x minus 20. We are looking for two numbers whose product should be equal to 7 times minus 20, right? So minus 140. And the sum should be equal to minus 31. So I just found that those numbers should be minus 35 and 4. So we found that these numbers could be minus 35 and 4, right? So whose product will be 140 and the sum will be minus 31. And I use this technique of factoring. So with minus 140, I kind of factored it and found that these are the numbers which could help solve our example. So whenever we are dealing with big numbers, here is a very good strategy. Now let's continue. So we'll split 31x, right? So we have 7x squared. 31x, we're writing this as 35x plus 4x minus 20. Now in these two, we can take 7x as common. So we get x minus 5. Here we can take 4 common. We get x minus 5. So x minus 5 is a common factor and we get 7x plus 4 as the other factor. So the numerator, which is 7x squared minus 31x minus 20, can be written in this form, and the denominator, x squared minus 25, can be written as difference of squares, right? X squared minus 25 is basically equal to x plus 5 times x minus 5, correct? So that is how we are going to factor. Now once we factor, then we can write the whole expression as ratio of these two, right? So we could write this as equal to, let me complete it here itself, numerator will be x minus 5 times 7x plus 4 divided by x plus 5 times x minus 5, correct? So from here, you see we could cancel the common factor, which is x minus 5, right? So what we get here is 7x plus 4 over 5x, x plus 5, right? So what we get here is 7x plus 4 divided by x plus 5. Clear? So that becomes an equivalent expression. Now if I leave it here, it is kind of wrong, correct? Because we didn't state the restrictions. Now this particular expression has only one restriction, which is x is not equal to minus 5. However, the original function has two restrictions. X is not equal to plus and minus 5. Therefore, in this particular case, it is important to state restrictions, and so we are going to write this here as 7x, let me rewrite the answer. We'll write 7x squared minus 31x minus 20 over x squared minus 25 is equivalent to 7x plus 4 over x plus 5, where the restriction is that x is not equal to plus and minus 5. Do you get this idea, right? So when you write the equivalent expression for a rational expression, you need to include all the restrictions which were there in the original function. Is that clear to you? So then only you get the right answer. Perfect? So I hope the concept is clear. So to get the rational expression, we need to factor numerator denominator, simplify right and lowest terms, and include the restriction. Perfect? Now let's apply the same strategy to solve question number 2. Question number 2. So I've changed the title here, find equivalent rational expression, right? Okay, so this is slightly different from what we saw last time. The numerator, let us expand this. 6 times x plus 2 could be written as 6x plus 12 minus 9. And we'll expand the denominator also. X times 2x is 2x squared. X times 3 is plus 3x. And then we'll multiply with 1. We get 2x plus 3. And we have minus 1 here, right? The numerator now can be written as 6x 12 minus 9 is 3, right? So plus 3 over, let's combine the like terms. So we get 2x squared, 3 plus 2 is 5, x, 3 minus 1 is 2, right? Now, let us factor this. So the numerator, we can take 3 common. So we get 3 common, 2x plus 1. And let's look into the denominator. We are looking for product of, so we are looking for two numbers p and q, whose product is 2 times 2, 4, and sum of p and q should be 5, correct? So clearly the numbers are 4 and 1. So I'll write the denominator as 2x squared. Instead of 5x, we'll write this as 4x plus x, and we have plus 2 here. Now, we can write this as 3 times 2x plus 1 over, you can take 2x common, right? So we get 2x common, we get x plus 2 plus x plus 2. And clearly, the numerator is 3 times 2x plus 1, and the denominator, we can take x plus 2 common, and we are left with 2x plus 1. Now 2x plus 1 and 2x plus 1 can be cancelled, and we can write this as equivalent to 3 over x plus 2. Now remember to write down the restrictions. In this case, we have two restrictions. One is that x is not equal to minus 2. The other one is that x is not equal to minus half. So to make it an equivalent expression, it is important to write both the restrictions, right? Only then 3 over x plus 2 will be equivalent to the given rational expression. Is that clear to you? Perfect. Now with that, let's move on and do some more operations with our rational expressions. In question number 3, we have to multiply two rational expressions and then divide by another one, and then equate it to an equivalent expression. Find the value of coefficients of x squared and x, add them up and match the answer. I'd like you to now pause the video, answer this question, and then look into my suggestions. Now I'll try to solve this in this very limited space. It will actually take a lot more space. So what we'll do now here is we'll factor each trinomial separately. So the first one here is 6x squared minus 7x minus 3. Right? We're looking for a product of 18 and sum of 7. Now to get product of 18 and sum of 7, it could be 9 and 2, right? So we could write this as 6x squared minus 9x plus 2x minus 3, and taking 3x common gives us 2x minus 3, and we have 2x minus 3 there. 2x minus 3 is common, and we get 3x plus 1. So that is the factor for the first one. Now 12x cubed minus 6x is simple, so we'll just do it direct. Okay. Now this one, let's factor 2x squared minus x minus 3. So that one we did. Let me just draw a line here. Okay. Let's do this one, 2x squared minus x minus 3. So when coefficient is not 1, it takes slightly longer, right? So you need 4 steps. Now we are looking for product of 6, sum of minus 1, so 3 and 2. So we get 2x squared minus 3x plus 2x minus 3. And so we can take x common. So we get 2x minus 3 plus 2x minus 3. So we get 2x minus 3 as a common factor, and we get x plus 1. Okay, so we know this now. Now this one is perfect square, and here 5 times 4 can work. So okay. So now let us try to solve this. So what we are given here is 6x squared minus 7x minus 3 over 12x cubed minus 6x times x squared plus 8x plus 16 over 2x squared minus x minus 3. Now division could be written as reciprocal of multiplication. However, we have to write restrictions for both numerator and denominator, right? So at present we have to write restriction that x cannot be equal to 1, but when you flip, we have to consider the factors of numerator. So we can write this as 2 minus 2x squared over x squared minus x minus 20. Clear? Now 6x squared minus 7x minus 3 is equal to this, correct? So we'll write this numerator as 2x minus 3 times 3x plus 1. Denominator, 12x cubed minus 6x, we can take 6x common, so we get 2x squared minus 1. Right. X squared plus 8x plus 16 can be written as x plus 4 whole square over 2x squared minus x minus 3, we factored here, it is 2x minus 3 times x plus 1. Now in this case, we have 2 as a common factor, and we get 1 minus x squared. So I could actually write this as, I'm clubbing 2 steps here, 1 minus x times 1 plus x. Right? Because 1 minus x squared is 1 plus x times 1 minus x. Denominator, minus 20 is the product, so 5 and 4. So we get x minus 5 times x plus 4. Is that clear to you? So that is what we get once we incorporate all our factors. Now let's cancel the terms which we can. 2x minus 3 can be cancelled, and anything else. X plus 1 can be cancelled, right? X plus 4 can be cancelled, right? So one of these factors vanishes. We could simplify this a bit. 2 goes 3 times. Okay, so that's what we get. Now this is a good time to write restrictions also. So let me include restrictions. Let me write them in a different color. So I'm going to write restrictions. So we say x is not equal to what? So let's begin from here. 0, right? So we get 1 as 0. Then here we get plus minus 1 over square root 2, right? Because this is x square minus 1, correct? 2 times x square minus 1. So we get plus minus 1 over, because you have to divide by this, right? Square root 2. Okay. Now in this case, the restrictions are x is not equal to 1 over 3 over 2, right? 3 over 2. Let me write this first. Okay, we write plus 1. It cannot be minus 1. Let's do this. And then for here, it is 3 over 2. Now this factor was division earlier, so we flipped it. So we have to take both negative and positive. So it cannot be 1. It cannot be 5. And it cannot be minus 4. So these are all the restrictions which apply to our rational function. Is that clear to you? So when you are dividing, you have to include restrictions of numerator and denominator both. Okay. So we kind of got a simplified expression, and okay. So now we can actually, I think there is a typing error here. We had 12x cubed so okay, so we can now write this as, I'll correct this here, right? There is an error here in typing. So what we really get here is, in the denominator we have the term 3x, and then we have this 2x squared minus 1, and these two factors cancelled. We have x minus 5. So if you compare with what is given to us, we have 3x, x minus 5, and 2x minus 1. That square thing is missing here, right? So let me include this, right? So I've just made a change here. There's a factor 2x squared minus 1. Okay. Now, let's look into the numerator. So in the numerator, we have these three factors, which is 3x plus 1 times x plus 4 times 1 minus x. Okay, so let us expand the numerator, and then we can easily compare. Is that clear to you, right? So let's do this expansion. So what do we get here? Okay. So first we'll multiply these two and then with 3x plus 1. So let me write this as 3x plus 1 times x minus x squared. With 4 we get plus 4 minus 4x, correct? Over the denominator, which is 3x times 2x squared minus 1 times x minus 5. Now, let's multiply by 3x. So we get what? 3x times x is 3x squared minus 3x cubed. And then we have, with 4, we get 4 times 3 is 12, so plus 12x. I could have added these terms. Anyway, now I'll multiply. 3x times minus 4x is minus 12x. With 1, we get all these terms, which is plus x minus x squared plus 4 minus 4x, correct? Divided by the terms 3x times 2x squared minus 1 times x minus 5. Clear? Now let's combine the like terms. So the first term, let's write the highest power minus 3x cube. Okay. Now take care of the x square terms. We have 3x square, and then we have, I think I missed, when I multiply 3x with 4x, I should have written 4x square, right? So 3x times x will give me 1x square terms, and with 4x I get another terms, right? 3 times 4, which is 12x square. Sorry, not here, but this place, correct? Yeah, minus 12x square. Okay, that makes sense. So we get this as our term, minus 12x square, and we have 1 minus x square here. So now let's combine this, 3x square minus 12x square minus x square, that gives us minus 10x square. Now the x terms, 12x plus x is 13x, and 13x minus 4x is 9x, so we get plus 9x, and then we get a number 4, right, divided by all this, which is 3x times 2x square minus 1 times x minus 5. Clear? Now if you compare with the given equivalent expression, we have ax square plus bx, coefficient of x square and b, right? X. So we have from here the value of a is equal to minus 10, and the value of b is equal to 9. So what is a plus b? So a plus b is basically minus 10 plus 9, which is minus 1. So our option A is the right option. Is that clear to you? Perfect. So that is how we could actually solve this particular question. You have to be really careful when you multiply these. I could have combined some terms x and minus 4x to reduce some terms in our expression. However, I hope you understand the process, correct? And it's kind of very important to write down all the restrictions which are valid for both these rational expressions, and only then we can say that both of them are equivalent. Is that clear to you? So I hope you enjoyed and you understood the concept to solve such complicated questions involving rational expressions. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.